Good morning, everyone. Today we are presenting our project titled Causal Effect of Social Media Uses on Student Well-being, a machine learning and causal interface approach. The motivation behind this project comes from the rapid growth of social media uses among the students and the increasing concern about its impact on mental health. Our concern is mental health, sleep quality, academic performance, and social relationship. While social media provides communication and learning opportunities, excessive uses may negatively influence student well-being. However, one major challenge is that the most available data is observational, making it difficult to us distinguish between simple correlation and actual causal relationship. The main objective of our project was twofold. First, we want to build machine learning models capable of predicting whether a student belongs to the high social media users group or low social media users group. We defined high uses as spending more than 4 and 8 hours per day on social media based on the median uses value in the dataset. Secondly, beyond prediction, we aim to explore how social media usage is associated with important well-being indicators such as sleep duration, mental health score, addiction level, and social conflicts. For this project, we used the student social media addiction analysis dataset collected from Kaggle. The dataset contains 705 student records and 13 features related to demographics, social media behavior, academic impact, mental health, relationship status, and addiction measures. We performed pre-processing to prepare the dataset. Since the dataset contained both categorical and numerical variables, we applied one hot encoding to categorical features and removed unnecessary variables such as student ID to avoid data leakage. We also divide the data into training and testing set 70-30 split and applied standard scalar to normalize scale sensitive models. Now our friend Sabbir Bhuyan will discuss further.
Thank you. My name is Sabbir Bhuyan. I will now discuss the explanatory data analysis, the machine learning implementation used in our project. We begin with EDA, exploratory data analysis, to better understand the data structure, feature distribution, and relationship among variables. We analyze numerical distribution, categorical frequencies, and generated visualizations such as histogram and correlation. Correlation heat maps. Uh, One of the most significant findings came from the correlation analysis. We observed a strong negative correlation between average daily social media usage and both sleep duration and mental health score. The correlation values were approximately minus 0.79 for sleep and minus 8.0 for mental health. This indicates that students who spend more time on social media generally sleep less and report poorer mental health condition. At the same time, we found strong positive correlation between social media usage, addiction score, and conflicts over social media, suggesting that excessive engagement increases compulsive behavior and interpersonal issues. So after pre-processing, we implemented 5 supervised machine learning models such as logistic regression, Classifier, K nearest neighbors, random forest, and XGBoost. The data set was split into training and testing sets into random state for of 42 To ensure reproducibility, logistic regression, reach, and KNN required feature scaling because these algorithms are sensitive to feature magnitude, while random forest and XGBoost did not require scaling due to their tree-based architecture. Among all the models, logistic regression achieved the best overall performance with an accuracy of 86.79% and an F1 score of 84.95%. The random forest and XGBoost also performed strongly while KNN produced comparatively lower results. We additionally implemented ROC and AUC analysis to compare the discriminative capability of classifiers. The ROC curves the ROC curves demonstrated strong predictive capability for logistic regression, random forest, and XGBoost, confirming that demographic, behavioral, and platform related features can effectively predict high social media usage pattern. And the next, I'm going to give the next floor. I'm going to give the floor to my next teammate, Mejba Uddin.
Thank you. I will now discuss the behavioral analysis and key findings, limitations, and future direction of our project. To analyze the relationship between social media usage and well-being, we divided students into two groups: high social media users and low social media users. Uh, uh, High social media users and low social media users. This division was based on the threshold of 4.80 hours of daily social media usage. Uh, Students above the threshold were considered part of the treatment group, while remaining students formed the control group. Our comparison between these two groups revealed several important patterns. Students in the high usage groups slept approximately 1.56 hours. Here are the visualizations. Hours less on average, and had mental health scores that were around 1.52 hours. Um, 5 2 points lower compared to low usage students. In addition, high usage students showed higher addition scores and more conflicts related to social media. These findings strongly support the hypothesis that excessive social media usage is associated with poorer well-being outcomes. We also perform a platform-based analysis to examine whether different social media platforms produce different behavioral outcomes. Here are our examination. Platforms such as TikTok, Snapchat, WhatsApp are associated with shorter sleep duration, uh, lower mental health scores, and higher addiction and conflict levels. In contrast, platforms such as LinkedIn, Line showed comparatively healthier patterns, including higher mental health score, lower addiction levels. From a system perspective, this may be explained by differences in platform architecture. Platforms like TikTok and Snapchat really rely heavily on short form media, continuous content delivery, and personalized recommendation algorithms that encourage prolonged engagement and repeated usage. On the other hand, platforms such as LinkedIn are more communication oriented and purpose driven, leading to more controlled user interaction patterns. Despite the strong predictive platform performance of our models, project has several limitations. The dataset is observational, self-reported, and cross-sectional, meaning the results should be interpreted as a strong association rather than proven causal effects. In addition, the datasets mainly contains student aged between 18 and 24, which limits the generalizability of the findings to broader populations. In future work, we plan to implement a stronger causal interference techniques such as propensity score matching, improve model explainability using shape analysis, and utilize larger or longitudinal datasets for more reliable causal estimation. Overall, our project demonstrates that machine learning learning can effectively predict high social media usage behavior while also revealing important associations between excessive social media uses and reduce student well-being. Thank you.